All right, in this video we're going to be doing more examples for exam 3, but we're going to be doing some gas law examples. Okay, we're only going to do a couple problems, but when we read through this we need to kind of pick which problems to, or which equation to use. We have one for initial and final conditions, and then we have 3 variations of equations for one set of conditions. And one is the ideal gas law, one has molar mass and mass in it, and one has density in it. And depending on what we're presented with, we need to pick which equation to use. Okay, so in this one, we have a sample of chlorine gas that has a pressure of 475 millimeters of mercury at 27.5 degrees Celsius in a volume of 12.5 liters. And we want to know what is the pressure at 49.6 degrees Celsius in a volume of 9.65. So essentially we have initial conditions and final conditions, and we need to see what happens. So the equation for that looks like this. This is the combined gas law. Okay, so let's kind of do an inventory of what we have. So P1 equals 475 millimeters of mercury. V1 is 12.5. T1 is 27.5 degrees Celsius, but we're going to need that in Kelvin. So if we add 273.15, the answer comes out to 300.65 Kelvin. Okay, N1. Honestly, if we look at this, there aren't any initial and final masses or any initial and final moles. So we can since the moles aren't going to be changing, we can almost ignore them. So in this equation, if there's anything that doesn't need to be, like if it's not mentioned at all, we're assuming it's not changing, so it basically will cancel out in the equation, which makes our math easier, actually. So P2, that's what we're solving for. What is the pressure? V2 is the volume, is 9.65. Okay, and the temperature, T2, equals 49.6 degrees Celsius. We need to add 273.15 to that, and that comes out to 322.75. Okay. So we have this equation and we're solving for P2, so we need to rearrange this equation to solve for P2. So P1 V1 over T1 equals P2 V2 over T2. We need to solve for P2. So we need to get rid of these two things, and whatever we do to one side, we have to do to the other. So to get rid of this T2 in the bottom, we need to multiply by T2 on both sides. So that'll make that cancel out. We need to do the same thing for V2. We're going to divide by it on this side, so we need to divide by it on this side. Okay, so P2 is all by itself on the top, everything else is on the other side. So I'm going to rewrite it like this. We have P1, V1, and T2 on the top, and we have T1 and V2 on the bottom. We have all of those numbers, so we're just going to plug it in. So P1 is 475 millimeters of mercury. V1 is 12.5 liters. T2 is 322.75. T1 is 300.65 Kelvin, and V2 is 9.65. Okay, so our units here, the liters will cancel out, kelvins will cancel out, and we have millimeters of mercury on top, and we want millimeters of mercury, so that works out really nicely. I didn't bring a calculator home, so I had to do this problem ahead of time, but basically if you plug everything in, the answer comes out to 661 millimeters of mercury. As far as typing this in your calculator, what I would recommend is hit 475 times 12.5, then hit equals. Then times 322.75, hit equals. Divided by 300.65, hit equals. Divided by 9.65, hit equals. And hopefully you get 661, assuming I did it right. Okay. So if you have initial and final conditions, this is a variation of what that type of problem might look like. Okay. Doesn't necessarily have to take up a full page. I was just trying to show all my work. Okay. For the next problem, what we have is we have a sample of gas has a volume of 1.61 liters at 325 Kelvin, a pressure of 4.50 atmospheres, and we want to know what is the mass. Well, we only have one equation in the mix that has a mass, and that's this equation. The capital M is molar mass, which you can get off the periodic table, but the little m is mass. And R is the gas constant, T is the temperature, P is pressure and volume. Okay? So let's do a little inventory of what we've got. Okay? So the capital M is the molar mass. Well, we know the formula and we can use the periodic table. If you add up a carbon and 4 hydrogens, it comes out to 16.043 grams per mole. Okay, molar mass. Little m is what we're solving for. R, we have a couple options. We have the 0.0821 liter atmospheres per mole Kelvin. We also have 62.4 liter millimeters of mercury per mole Kelvin. So the only difference between those two equations is the pressure unit. Since this is in atmospheres, we want the 0.0821 liter atmospheres per mole Kelvin. So the unit of pressures is what decides which R value we like. Temperature, it's already in Kelvin, so we're good. 325 Kelvin. Pressure equals 4.50 atmospheres. And the volume is 1.61 liters. Okay, now we need to rearrange this equation for the little m because it asks what's the mass. Okay, so I'm gonna rewrite it and show all my work. So we need to get rid of oops, so to be a V on the bottom. We need to get rid of anything that isn't m on this side. Okay, and whatever we do to one side, we have to do to the other. I may not have left myself enough space, but that's all we need to do. Okay, so we just need m by itself, so this r and this t are both in the top. We need to get rid of them, so we're going to divide by both of those. Whatever we do to one side, we have to do to the other. We also have p and v in the bottom. Sorry about the handwriting issues. We need to multiply by p and v to get rid of that. So we'll have m by itself. The equation we have left has this capital M times p times v all on the top, and r and t on the bottom. Okay, well, if we plug everything in, this is 16.043 grams per mole. P is 4.50 atmospheres. V is 1.61 liters. R is 0.0821 liter atmospheres per mole Kelvin. And T is 325. Oops. All right, there's a lot of units here. The liters will cancel out, atmospheres will cancel out, moles will cancel out, and kelvins will cancel out. So the only thing we should have left is grams. If you plug everything in, again, I would type 16.043 times 4.5, hit equals, times 1.61, hit equals, divided by 0.0821, hit equals, divided by 325, hit equals. Again, multiply anything into the top, divide anything into the bottom, hit equals a lot. Anyway, the answer you get is 4.36 grams. Okay, so, yeah, hopefully these videos help. I'll see what else I can do, I guess. Thanks.